Hey guys, this is going to be a review video for the 12-1 quiz. So let's go over some of the basic trig stuff first. All right, so here is a right triangle, and we want to find the 6 trig functions for angle theta. Now remember, we have to have all of our side lengths to be able to do this. We have the hypotenuse, and if we're looking at theta here, we have the opposite side. So we're missing our adjacent side. So let's set this up with Pythagorean's theorem. Let's just say that the adjacent side is x. So x squared plus 18 squared should equal the hypotenuse squared. So then I'm just going to solve for x here. X should be equal to the square root of 21 squared minus 18 squared. Okay, and that calculation is going to give me the square root of 117, which I can break down. I know you're all happy about breaking down radicals again. It's going to break down into the square root of 9 times the square root of 13, which simplifies to 3 radical 13. So that's the value that we're going to be using for our adjacent side here. So now we can do our trig functions. Okay, sine of theta is going to be 18 over 21, which is going to reduce to 6/7. Cosecant then, which is the reciprocal of sine, would just be 7 over 6. Cosine is going to be 3 radical 13 over 21. I can reduce the 3 over 21 to 1/7. So this is really radical 13 over 7. And then secant would be the reciprocal. Okay, but if I rationalize, I'm going to get 7 radical 13 over 13. And then lastly, we have tangent here, which would be 18 over 3 radical 13. Now, the 18 over 3 is going to reduce to 6, and then I'm going to rationalize. So I'm going to get 6 radical 13 over 13. Now, I'm skipping some steps here. I should write this out better. Okay, what I'm doing is I reduced first, and then rationalizing, remember, means to multiply by that square root that's in the denominator. So this would give us 6 radical 13, and then square root of 13 times square root of 13 is just 13. So that's what I'm doing here. The process isn't too crazy, so I'm just doing it in my head here. So then cotangent, remember I should probably look before I rationalized to get my reciprocal. So I'm going to have 3 radical 13 over 18, and then I can reduce 3 over 18 to 1 over 6 to get radical 13 over 6. And there we go. There are all 6 trig functions for angle theta. So let's find some missing measurements. Now, whenever you have these, it's never going to be any of the reciprocal functions. It's going to be one of the 3 that you're very comfortable with. Okay, think SOHCAHTOA. Based on this angle, I have my opposite side, and I have my hypotenuse. Okay, so you just need to think SOHCAHTOA. Which of my functions uses the opposite in the hypotenuse? That's going to be sine. Okay, so sine of 42 degrees is equal to x over 14. Multiply both sides by 14. And now I'm ready to calculate that missing side length. Now remember, your calculator needs to be in degree mode since we have angle measurements in degrees. So when we make this calculation and round to the nearest tenth, we get x equals 9.4. Okay, another one. Based on my angle here, I have the opposite side and the hypotenuse. So again, I'm going to be using sine. But this time, X is not in the numerator, it's in the denominator. So remember the trick here. I multiply by X on both sides, and then I'm going to have to divide by sine of 18. So if I divide by sine of 18, it ends up in the denominator here. And when I do this calculation, it comes out to be 68. Now remember, we can also find missing angle measurements. So here I just have angle theta that I'm trying to find. I have the opposite and hypotenuse. So we're using sine again, but this time it's sine of theta equal to 34 over 35. And we have to do inverse sine of both sides to solve for theta. So inverse sine of 34 over 35 would give us an angle measurement of 76.3 degrees. So let's see another one like that. Okay, this time we have the adjacent and hypotenuse. So we're using cosine now. So we set up that ratio, and then we're going to do inverse cosine of both sides. Now, I should say that to get that inverse cosine button, remember you're going to hit second cosine on your calculator, and you should see the cosine to the little -1 power when you do that. And then you're just going to stick the fraction inside, and that should give you an angle measurement of 34.3 degrees. So let's talk about angles. Okay, so we are given an angle of 305 degrees. Before I do anything else, I'm going to stop and I'm going to sketch that angle. Now remember, positive angles go counterclockwise. So this one is going to end about right here. That's 305 degrees. And I need a positive and a negative coterminal angle. So typically to get a positive coterminal angle, you take your original angle, you add 360. Okay, so that would give us 665 degrees. And then to get a negative coterminal angle, we take our original angle and we subtract 360 degrees, which will give us -55 degrees. Now, the reason that that works is because 360 degrees is one revolution. So adding 360 just means we're starting where we were and we're doing an extra loop counterclockwise. And then subtracting 360 means that we're starting at that terminal side, we're going a full revolution clockwise and ending up at the same spot. So remember, coterminal angles are just different ways to measure the same terminal side. Now, a reference angle has two requirements. It has to be positive and it has to be acute. And it's really just the measurement from the terminal side back to the x-axis. So that right there in blue is our reference angle. So remember that we had a 305 degree angle. To get back to the x-axis here, we would have to go 55 more degrees. So that is my reference angle. So let's do one more like that. Okay, so we have 7 pi over 10. I'm going to convert this to degrees. And that's going to give me 126 degrees. So let's sketch this. So about here. So I'm going to get a positive coterminal angle by adding 360. And I'm going to get my negative coterminal angle by subtracting 360. Now my reference angle is going to be the measurement here from that terminal side to the x-axis. So we went 126 degrees. To get to 180 over here, we would have to go 54 more degrees. So that's our reference angle. So the last thing I want to do is I want to go through some word problems with basic trig stuff. So remember that this really comes down to just being able to draw a picture that represents what's going on. You should have a right triangle in it, okay, and you're just going to be solving for an angle or a side. So let's see what we've got here. It says from the top of a building, the angle of depression, so we'll have to be careful here, to a car parked on the street below is 48 degrees. The building is 75 feet tall. We're trying to find how far the car is parked away from the base of the building. So like the horizontal distance between the base of the building and where that car is parked. So let's draw a picture here. So there's the ground. Here's the building. And then here is my very, very bad car. Okay. Now remember, we're on the top of the building and we're looking down. So our triangle is like this because the angle of depression is this angle here. So that angle is 48 degrees. Let's see what else we know. The building is 75 feet tall. Now, the building's height would be here, but I'm going to mark it over on this side. Oh, not degrees. Wrong unit. Okay, and I know my picture isn't perfect here, but you guys get the idea. We're trying to find the distance between the building and the car. So that would be this distance here. So we need to think about what sides we have. Based on that angle, we have the opposite and we have the adjacent side. So we should be using tangent to solve this here. So tan of 48 degrees is equal to 75 over x. So we need to multiply both sides by x. And then we're going to divide by tan of 48. And then we find that that missing measurement is 67.5. So that means that the car is 67.5 feet away from the base of that building. All right, one last one, and this one is a little trickier. So this one has already given us a diagram because it's a little trickier and a little more confusing, and it's very likely that you would draw the picture wrong without having it given to you. So it says that we have this tower. Okay, it's a cell phone tower, and there is a 95-foot wire attached from the top of the tower to the ground. So the wire is this line right here. Now, we know two pieces of information here. We know that this wire is 95 feet long. And we know that it makes a 62-degree angle with the ground. Okay. Now it says Joey is standing 150 feet away from the end of the wire. Now, don't mislabel this. The end of the wire is right here. So that means that this distance is 150 feet, not the entire base of the triangle, the big triangle, I should say, but just from Joey to the base of that wire. And he's looking up at the tower, and we want to find the angle of elevation from the point where he's standing to the top of the tower. So the missing angle, theta, that we're looking for is right here. Now, we're missing a lot of information. There's a lot of things we need to find before we can find theta, because the larger triangle, you can't see that very well. This larger triangle is what theta is an angle of, and we have half of the base, and we don't have a hypotenuse, and we don't have a height. So we need to use the smaller triangle with the wire in the tower to find the rest of this base distance that I'm going to call y, and this height of the tower that I'm going to call x. No particular reason I'm using those, just because that's why. So let's use this 62-degree angle and this 95-foot wire to help us calculate these. Let's find x first. Let's find the height of this tower. Find x. So if we're finding x, x would be the opposite side of this smaller triangle we're looking at, and 95 feet, that wire, is going to be the hypotenuse. So that means we should use sine. So sine of 62 is going to be equal to x over 95. So then we can multiply both sides by 95, and we find that x is equal to 83.9 feet. So I'm going to erase this here, and I'm going to put that 83.9 feet. Okay, and then we need to find y now. So if we're finding y, that's really the adjacent side. So the adjacent side in the hypotenuse would be cosine. So cosine of 62 is equal to y over 95. So we can multiply both sides by 95, and we would get y is equal to 95 times cosine of 62. I'm just going to calculate it here to save some space. That's going to give us 44.6 feet. So again, I'm going to erase this and rewrite it. Now, keep in mind that now we can find the entire base of that triangle. We have the height, that's the 83.9. I need to know the base, so I'm going to add the 150 and the 44.6 together to get 194.6 feet. Oh, I'm saying one thing and writing another. And now I have everything I need to find theta, finally. To find theta, I'm going to use tangent because I have my opposite side and I have my adjacent side. So I'm going to set this up as tan of theta is equal to 83.9 over 194.6. And then we need to do inverse tan of both sides. And that's going to give us an angle measurement of 23.3 degrees. So that was a lot of work, but we got there. So I wanted to do this one because you can see lots of different steps and lots of different equations and things set up here. You're not usually going to see one this challenging, but it's definitely a possibility. So just know that you can do a lot of different steps inside of one problem and set up lots of different trig functions to help you find missing angles and missing side lengths. So I hope that this video was helpful. Remember, I have this PDF posted if you want to like print it off and do the problems, follow along. So let me know if you guys have questions, reach out with concerns, and have a great day.